Hello guys, welcome to Sustainable Truth. I am your host Otis, and today we will cover Tesla full self-driving and Dojo on AI Day 2. I'm going to simplify the information given in the long event and break down things that you should know. Stick around and let's go! In Q&A section after the presentation, Elon stated that he wants to shift perception of Tesla being just a car company and to show people that they're one of the leaders in AI in the world. Let's see why. What full self-driving team has achieved over the last year? Company went from 2,000 customers using beta in 2021 to 160,000 customers in September of 2022. Breakdown of full self-driving. Let's break down full self-driving and see what's under the hood.
Okay.
We have two main neural networks or brains in full self-driving. Of course, there's a lot more, but let's keep it to two for now, as it does get confusing very fast. Occupancy, lanes and objects. Occupancy and lanes with objects are the visual side of full self-driving. It's how it sees the world and elements in it, for example, trees, walls and other objects. It's basically like a human eyesight or cameras in a car or a robot, taking in information and making sense of what it's seeing. How exactly it does this is quite complicated. You can check out the full video Tesla presentation if you want more details. It also predicts next action of those objects, anticipating the next possible moves. The same way as you would anticipate a person walking onto the road just by seeing them approaching a road crossing, for example. Okay, so full self-driving can now see around it and anticipate moving objects. What do we need next? Well, the destination, of course. How will it get there? Not just planning the route. That's the easy part. It needs to plan its every decision involving different factors. For example, once the car approaches intersection, it has to decide which is the best way to proceed. It has to know the rules of the road. It has to look at the best scenario to cross and merge in a safe manner, but also time efficiently and with passengers' comfort in mind. This network layer has to make many different probability calculations in a very short period of time. They branch out different scenarios and weigh them for the best outcome. Tesla has developed another neural planner to help speed this process up. To determine the best action to take, it then runs collision check simulations as well as comfort analysis to make sure it's a smooth crossing for everyone. They then take those actions and reference it with Tesla's fleet data where a person has made an intervention or took over the wheel. And then, on top of all that, they compare it with more data of people actually driving themselves in that particular scenario to compare the path that the car is going to take. There's a lot layers to this and I know it gets confusing. I'm only mentioning the main ones, but just for more fun, let's add another one.
Okay.
Tesla uses cameras to form 360 view of the surroundings and in obscured areas. For example, another car or object blocking the way to see the road on an intersection where the car needs to proceed. It will run a simulation of potential multiple cars coming if it cannot see that the road is clear to proceed. The computer does not see them, but that doesn't mean they are not there. If our view is blocked of the road, we will not just blindly drive out. We will creep and check to make sure that we don't crash. Well, most of us will.
Sammy, you are wrecking the car! Shut up!
This basically serves the same purpose: training infrastructure. To train these networks, Tesla had to build 3 in-house supercomputers with the power of 14,000 graphics cards and 30 petabytes of video. That's 30 million gigabytes, with 500,000 videos rotating each day. They talk a lot about the hardware and specifications needed to train the networks, but it is very in-depth and my brain has left the room. But if you are interested in the details, check out the full presentation. So the big question now, how they put all this into a car? Well, it's very simple, they just do an over-the-air update and it's done.
Duh. Bruh.
But to be honest, I'm not exactly sure. They process all layers and networks through different tools and it gets optimized to be able to run in the car using its computer alone. And those are the car computer, or brain if you will, operations running in the car. It really does look like a human brain, doesn't it? Full self-driving teams are also working on new auto-labeling technologies to tell the software what it's seeing. This helps a lot with bad weather conditions, as the car will have the lane data from other situations. Another training advantage from this is they can create simulation with that data, so they can recreate real-world roads in virtual reality and train the car in different weather conditions and situations that are not likely to happen in real life, like emergency situations and things you don't see every day. They include road signs and traffic lights into it as well. All done automatically in minutes. No human intervention required. So basically, full self-driving AI is creating virtual video games without human intervention. With Unreal Engine 5 also. That means good graphics. So to summarize, a Tesla owner will report issues on a certain intersection. The computer will automatically make it into a virtual reality and train it in many different weather and traffic conditions with different scenarios at the same intersection thousands of times virtually, all done automatically. So for all these neural networks, storage and training required, Tesla needs a lot of computing power. That's where DOJO computer comes into play. DOJO computer. DOJO computer was built in the need of computing power for a specific neural training. So it's built different from other supercomputers which are more general purpose. Tesla was searching for a computer that they could use for its massive amounts of training, but decided to build it in-house. They did not go with off-the-shelf parts and just build a massive data center. They vertically integrated the hardware, redesigning it from scratch. Reason being, the speeds that they need cannot be achieved by conventional machines. The purpose of DOJO. The goal of this computer is to build one giant accelerator. So think of it as one massive graphics card in a computer, instead of having many small computers connected over the internet, running slower as they would have to send the information between them. They had many failures along the way and had to come up with new ways of powering, cooling, and dealing with vibrations, etc. Engineers already load tested the cabinet, but they tripped the substation, pushing over 2 megawatts of power. So the infrastructure that's needed around this is also very important. Tesla team also built the software specifically for the task, with unique ways of managing this new architecture. DOJO, once completed, will accelerate the training times by an order of magnitude. They are comparing results with NVIDIA's N100, current most popular solution for AI training. DOJO is definitely a better solution, replacing 6 GPU boxes with one DOJO tile. The tile costs less than one GPU box, so a massive reduction in cost. So the networks that took a month to train will now be done in less than a week. Elon has stated that it would make sense for them to have a cloud-based services model regarding DOJO. So this puts them in the lead for cost over performance, therefore having the ability to offer web services cheaper than competitors. It should be operational in Q1 2023. I think this is another income stream for the company stock analysts are not considering, and once it's built, it will have huge margins. I hope this explanation helps. It is quite technical and in-depth. I'm sure I got some details wrong, so please correct me in the comments below. Guys, thank you so much for watching until the end. If you enjoy, hit like and subscribe. It helps YouTube promote this content. I want to provide value to as many as I can, so this helps a lot. Any thoughts or feedback would be much appreciated in the comments below. Thanks again, and I'll see you on the next one.